Hi everyone, this is Vantage Tutorial, and in this video we are going to be learning about anomalous behavior of water. So what we are going to do is that I'm going to explain the concept and we are going to look at some UTME PQ on this concept. So this particular topic, it's in chemistry as well as physics. So if you get to know it now, you've known it for like the two subjects, and if you come across any question on it, you'll be able to like tackle it heads on. Without any further ado, let's dive in. So let's start. What is anomalous? Anomalous actually means abnormal. It means abnormal. So an anomalous behavior of water we are talking about, it occurs within a particular range of temperature, and the temperature range is 0 degrees C to 4 degrees C. Please take note, 0 degrees C to 4 degrees C. So before I explain further, let me explain something. You know, we have three states of matter. We have the solid, right? We have the liquid, and we have the gas. So normally the normal trend is this. You know, we have something called change of state. We can convert from one state of matter to another. If I convert from solid to liquid, my expectation is that the volume is going to increase. And if I convert from liquid again to gas, the volume will also increase. These arrows for increase. Sure, you understand? And if I'm converting backwards, so from gas to liquid, the volume will decrease. Volume will decrease. And from liquid again to solid, the volume will also decrease. That's the normal trend. But for water, at a particular temperature range, water does not follow this expected rule. And that temperature range is 0 degrees C to 4 degrees C. Aside from this temperature range, water will follow the normal rule. So what am I talking about? You know, when you have your palm oil, which is liquid, and during cold season you allow it to be, at some point everything will come together and turn to a semi-solid. You are going to realize that the volume that semi-solid is going to occupy will be lesser than what the whole normal liquid palm oil occupy. So that's a typical example. That's how normal liquid does. When you freeze them, convert them from liquid to solid, they are going to occupy less volume. And also, if you are familiar with butter, those that use butter to prepare food, if you melt butter, a small amount of butter like this, when you melt it, the volume may be more, and if you freeze it back, the volume will shrink. What I'm trying to say is that whenever a particular liquid is converted to solid, the volume should decrease, and when the solid is converted back to liquid, the volume should increase. But for the case of water that I'm talking about, between this temperature range 0 degrees C to 4 degrees C, water does not obey that rule. So at 0 degrees C, you are going to agree with me that water will be solid, it will be ice. Instead of the volume to decrease, the volume will increase. So at that particular temperature, the volume will have a maximum, the water will have a maximum volume. So what's my proof for that? If you have your water in a sachet, like the normal pure water, the sachet water, if you freeze it, you are going to understand that it will be expand more, it will occupy more volume. I don't know, at some point you even some of the water will even tear the sachet. So, and if you remove the ice block and put it in a cup, you are going to occupy that. When you understand that when it melts, it's going to occupy the volume will be less. It's going to occupy less volume of the container. So that's what you're talking about. So at 0 degrees C, let's get that right, water will have a maximum volume, while at 4 degrees C, water is going to have a minimum volume. Now another thing I want you to understand is this. We have something we called density, right? And density is inversely proportional to volume. So if I said that water is going to be maximum at 0 degrees C, it's going to have a maximum volume at 0 degrees. What do you think will happen to the volume? Will happen to the density rather. The density will be minimum at that 0 degrees C. density will be minimum. Why at 4 degrees C? If the volume is minimum at 4 degrees C, automatically the density will be what? Will be maximum. Take note of those two things. At 0 degrees C, water will have a maximum volume, while at 4 degrees C, it's going to have a minimum volume. But at 0 degrees C, the density of water will be minimum, while at 4 degrees C, the density of water will be maximum. So aside from these two temperature range that I've explained, water will behave normally. So which means that from 4 degrees C to 30 degrees C now, as I'm increasing the temperature, I'm tilting towards making it a gas. Water, it has a minimum volume here, right? Minimum volume, right? And what? And maximum density at 4 degrees C. So, but for the fact, let's say 200 degrees rather, to the same point, once I'm increasing temperature, the volume will be increasing because it's going towards gas. The volume will be increasing as I'm increasing temperature, while the density will be decreasing. Do you get that? So let me take like a summary of what I've said. We have something called anomalous behavior of water. It's abnormal behavior of water, and it occurs between 0 degrees to 4 degrees C. At 0 degrees C, water has a minimum volume, while at 4 degrees C, at 0 degrees C, water has a maximum volume, while at 4 degrees C, water has a minimum volume. At that 0 degrees C, in relation to the density of water will be minimum, whereby the volume will be maximum, right? While at 4 degrees C, the volume will be minimum, while the density will be maximum. But aside these two temperature range, there's going to be a normal observation of the normal trend of change in state of matter with respect to volume and density. So if I keep increasing the temperature from 4 degrees C upward towards the same point, the volume of water, which is minimum at 4 degrees C, will start the volume will start increasing and the density will start decreasing. So it will be tilting toward gas so that the volume will keep increasing. Now, having understand that, let's solve some UTME past question. The first one we have here, they said, water shows anomalous behavior. A, below 0 degrees, is that correct? No. Between 0 degrees and 4 degrees, that might be our answer. Let's check the other option. At exactly 4 degrees, no. Between 4 degrees and 100 degrees, no. That's our answer is B, between 0 degrees and 4 degrees. It's a 1985 UTME question. Let's check the second one. They said, when left in a freezer, a bottle full of water cracks on freezing into ice because of the dash. So they're asking us what really happened that makes it the bottle to crack when the water is freezed. A, decrease in the volume of water. Is that true? No. If the volume decreased, it should not affect the bottle. Contraction of the bottle, no. The bottle will not contract. Expansion of the bottle, no. Increase in the volume of water, yes, that's correct. That's because we know that at 0 degrees C, water will have a maximum volume. Now the next one, they said a quantity of water at 0 degrees C is heated to about 30 degrees C. At each degree rise in temperature, its density will, what will happen to density? They said between 0 degrees C to 30 degrees C. We understand that anomalous happen between 0 degrees C to 4 degrees C. So between this 0 degrees C to 4 degrees C, at 0 degrees C, volume will be maximum, but density will be what? Minimum, right? So if I'm heating it now, volume will be decreasing, but density will be increasing, which means that between 0 degrees C to 4 degrees C, the density will rise. But between 4 degrees C to 30 degrees, what will happen to density? Between 4 degrees to 30 degrees C, water will observe normal trend, which means that the volume will be increasing and the density will be decreasing. So the density will firstly rise, then fall. So let's check which one that give us that option. Rise steadily, rise then fall steadily, fall then rise. It should be rise, then fall. So B is the answer. Thank you very much. It's Vantage Tutorials.